Humans are bathed in starlight. The universe, where do we come from? Whether an Earth-like planet exists. With the other eye, astronomers will look to the stars for answers to all their questions. Through census work, we can know people's age, sex, education level, family composition, and so on. Sky surveys are mass surveys of celestial bodies, similar to census surveys. The earliest astronomical observation was the observation of the sky by naked eye, and the constellations were the result of the observation by naked eye. The most important photographic surveys in the history of astronomy are the Palomar-Schmidt survey in the Northern Hemisphere and the British Schmidt survey in the Southern Hemisphere. The Big Bang cosmological model has been widely accepted since the discovery of the cosmic microwave background in 1967. Cosmological research has entered a new era of rapid development, and an accurate and digital survey of the whole universe is urgently needed. In the 1980s, China and the rest of the world put forward a digital sky survey with large field of view and large sample at the same time. The first was the BATC Multicolor Survey. Over the past 26 years, the project has trained many young astronomers in the field of large field and large sample research in China. During this period, China has also put forward a number of optical sky survey plans, such as the Antarctic Observatory's Sky Survey Telescope and the Sky Survey Telescope jointly constructed by the University of Science and Technology of China and the Purple Mountain Observatory. As dusk falls, the Lemos Dome opens at the Xingleng Station of the National Astronomical Observatories, about 200 kilometers north of Beijing, allowing astronomers to peek into the Milky Way secrets. LAMOST is short for Large Area Multi-Target Optical Fiber Spectroscopic Telescope, and its Chinese name is Guoshojing Telescope. Its current mission is to survey the Milky Way galaxy. Unlike optical telescopes, LAMOST does not look directly at a star, but captures the visible spectrum of the star. Scientists analyze the spectra to get information about distant stars. LAMOST is known as the king of spectroscopic sky surveys, because it can observe 4,000 objects simultaneously, compared to the current maximum of 640. Its original observations are processed into a series of data products that can be used by astronomers. Finally, these precious scientific data are gathered in the Chinese Virtual Observatory and made available to the world. By the time of the 8th data release, LAMOST had released more than 17 million spectra, making it the world's largest celestial spectral database. These data are the basis for astronomers to study the properties of all kinds of objects that are giving us a new understanding of the Milky Way. In addition to ground-wide field of view optical sky survey, another development direction of sky survey is from ground to space. Tianhe, the core module of China's space station, has been successfully put into orbit, and China's space station will soon be fully completed. But it is not alone in space. It will be accompanied in orbit by a 2-meter optical telescope, the China Space Station Telescope, also known as the Sky Survey Optical Module, which is scheduled to be launched in 2024. The Survey Optical Module has a wavelength range of 255 to 1000 nanometers, covering near-ultraviolet, visible and near-infrared wavelengths. With an effective field of view of about 1.1 square degrees, about 300 times the effective field area of the Hubble telescope. The optical module can not only fly autonomously with high attitude adjustment accuracy, but also have the ability to actively rendezvous and dock with space stations. It can receive propellant refueling and perform maintenance, repairs and upgrades to equipment while docked to the station. In the next 10 years, the optical module will conduct a large area polychromatic imaging survey and a large area seamless spectral survey, and then conduct a detailed survey of the selected sky area polychromatic imaging survey. As China's flagship space observation facility for the next 10 years, It will observe gravitational lensing effect and large-scale structure in cosmology, and study dark matter and dark energy in the universe through data obtained from 10-year sky surveys. China's other big science facility, FAST, will also cooperate with the Sky Survey optical module in areas such as fast radio bursts. Our fascination with the universe has never been stronger, and when we look up at the stars, we see stars that are not exactly what they are. The China Sky Survey will lead us to explore the past and future of the universe, and understand their moving story in this long time.